All right, we're going to start our similarity unit with section 1 on ratios and proportions. This unit, or this section especially, is going to be very algebraic in nature, so we will look at some figures and some diagrams and tables and such, but a lot of what we are doing will be just kind of crunching the numbers. So let's go into some terminology right away. A ratio is a comparison of two or more numbers. It can be written in words as a fraction or with a colon. So if we are looking at a ratio of girls to boys in a classroom, can be written in words. So we'd say 2 girls to every 3 boys or something like that. So like 2 to 3. As a fraction, we can say that would be like 2/5 of the class is girls, or 3/5 of the class is boys. So that would be a ratio of like boys for the total class, or girls to the total class. Or you can write it with a colon, and the colon just kind of implies that word two. So like 2 chairs to every 1 table, 2 to 1. You'd use a colon there. Proportion is an equation that sets two ratios equal to each other, and it usually uses the fraction setup. I'm going to erase this. This down here, this is a proportion. When we have A over B equals C over D, that is a proportion. Then the cross product property is a way to solve proportions by multiplying the numerator of one ratio by the denominator of the other ratio, and then setting your two products equal. So I'll show you a little example of how that works. So again, here is a proportion. A over B equals C over D. So I would set the numerator of this one times the denominator of this one, A times D. Have that right here. We'd set that equal to B times C. So again, numerator of 1 times denominator. Now why it's called the cross product is because we can do B times C, kind of going across like this, and A times D, going across like that, and they crisscross and make kind of an X shape there. So that's why it's called the cross product. If we have this proportion, one ratio equal to another ratio, cross them out like that, take their products. A times D is the same as B times C. So let's use some of these ideas or some of these techniques to solve example 1 here. Betty's Bagels, I guess that's a shop. She kept track of its sales for 1 day. The data is reflected in this table below. So the type of bagel that was sold is given over here. Plain bagels, cinnamon raisin, sesame, garlic, whole grain, everything. And the number of each of them sold. So 80, 30, 25, 20, 45, 50. If we add up all of these numbers sold, we'd get the total number sold for that day, which would come out to 250. So she sold 250 bagels in that 1 day. So looking at some of our questions here, what is the ratio of plain bagels sold to sesame bagels sold? So just however many plain for however many sesame. So the plain number is 80. And again, we see that right here. Plain bagels, that number is right here. Number of sesame bagels, we're looking for sesame, and that's right here. So 80 to 25. There are 80 plain bagels sold for every 25 sesame seed or sesame bagels sold. Now we can simplify that. If we were to think of that as a fraction, here we see the ratio written with a colon. If we wrote it as a fraction, 80 over 25, we can divide both of them by 5. We'd simplify down to 16 to 5. There are 16 plain bagels sold for every 5 sesame bagels sold. Continuing on, I'm going to try to keep that table there. What is the ratio of garlic bagels sold to the total bagels sold that day? So again, then we have our total number here. We can see total is this number right here. And our garlic, that number is right here, 20. So we'd say that it is 20 to 250. So again, I wrote it in the colon form. You can write it in words as like 20 to 250 if you want, or if you wanted to make it a fraction, that is fine as well. But it'd be 20 to 250 of them. We can reduce that then, or simplify it, divide both of those numbers by 10, and we'd simplify it to 2 for every 25, 2 to 25. there are 2 garlic bagels sold for every 25 total sold. If during a week Betty sells 2,200 bagels in total, how many of them are going to be whole grain? Well, again, we know our total for one day, and we know our whole grain for one day is 45. So we can start by making that ratio whole grain over total. Now, if we want to know the same for a week, so in a week we know that we can sell 2,200, but we don't know how many whole grain that would be. We'd set up our proportion to look something like this. Whole grain over total equals whole grain over total. So in both cases, total has to be on bottom, whole grain on top. So make sure your labels match. Now that we have a proportion set up, now we can cross multiply. 45 times 2,200, 250 times x. That'll come out to 250x equals 9,999. We can divide both sides by 250 to get x alone, and we'd find out that x equals 396. So we would say there are 396 whole grain bagels sold in 1 week. Example 2, Pete is building a new barn. The table below represents his actual and his scale measurements. So his actual length of his barn is going to be 16 feet, so the length on his scale drawing is 4 inches. Now, these are given in inches, these are given in feet. So to make sure that we have kind of comparable numbers here, we want to change one of these to match the other unit. So we could change this into like 1/3 of a foot, but then we're using fractions and decimals, and I mean we already do have some decimals, but they'll be really small. It might be harder to work with. It might be easier. We're going to change these ones to inches because it's a lot. It's simpler just to do multiply by 12. So this one is going to be 192 inches. This is going to be 300 inches, and this one's going to be 120 inches. That'll make things nice and easy. So the last number that we don't know, in this case, is the length on the scale drawing of his water line. So what is the length of the water line supposed to be in the scale drawing? Well, we'd have to start by setting up our proportion. Oops, get this out of the way. There we go. We'd say 4 inches scale drawing for the door opening to every 192 inches. That's his actual length. So scale over actual from one that we already knew. Now I could use 6.25 over 300. I could do that just as easy because this is one ratio that fits, but I'm going to use 4 over 192 because there are no decimals in that one. Now we need to set that equal to this unknown number over 120. Again, scale on top, actual on bottom. Now that I have a proportion, I just cross multiply everything, and we would get 192x, or that unknown number, equals 480. I just cross multiplied them. Dividing both sides by 192, I would get x equals 2.5 inches. So on our scale drawing, that water line is going to be 2.5 inches. If Pete recorded a scale length of 5 inches for a window, so that's on this side, our scale length, what is the actual length of the window? So we need to make another proportion. I'm going to use that same 4 over 192, like we did over here. In this case, though, when I make the proportion, I have the scale length, that 5. Oops, bring this down. I have that number 5. What I don't have is the actual length. So on the bottom, that's going to be our unknown. That's going to be our x. So this is how I'd set up my proportion. Cross multiply to obtain that new equation. 4 times x is 4x. 192 times 5 becomes 960. Dividing both sides by 4 to get x alone, I would get x equals 240 inches. I could leave it in inches, or since all of these ones seem to be in feet, I'm going to break that down into feet, divide it by 12, and get that it's going to be 20 feet. So if we had 5 inches on this side, it would be 20 feet on this side. If Pete were to measure his actual window to be 3.75 feet wide and recorded its scale measurement as 0.85 or 0.85 inches, is he correct? Why or why not? Now again, all of these are in feet, just like this one is in feet. We want them in inches. So times it by 12 and we get 45 inches. So when we set up our proportion, 4 over 192, that we've kind of been using a lot, is what over 45. So scale over actual is scale over actual. The actual should be this 45. Cross multiplying these ones and we would get 192 times this unknown number, or 192x, equals 4 times 45 becomes 180. Divide both sides by 192 to get x alone, and we'd find that x equals 0.9375. So it's not quite this 0.85. Now, if we look at all of these numbers, 16 and then just divide by 4 gave us 4 inches. 25 divided by 4 gives us 6.25. 10 divided by 4 gives us this 2.5 inches. So it might seem like we can just divide everything by 4, divide your feet by 4 to get your inches. So if we try that here, 3.75 divided by 4, we would get 0.85. So why didn't that work in this case? Why didn't it work just to do divide by 4 and get down to our exact inches measurement? Well, the reason it doesn't work is because feet doesn't use 10 scale, or from its inches. There are 12 inches in a foot. There are not 10 inches in a foot. So when it's not whole numbers like this, 16, 25, 10, when we're not using whole numbers, when we have a decimal here, you can't just divide by 4. It'll get off. So first you need to change it to the inches, like we did here, so that we'll get exact measurements every time. So make sure to always change them so that you're in the same unit, inches and inches, or feet and feet, or miles and miles, or meters and meters. Get them all in the same units before you start comparing them. And I think that's going to wrap it up for our first video.